Okay, hello friends. How are you? I think all are fine. Good morning, everyone. Today we will start with a new concept of Python. As you all know, Python we are studying, so we will consider now data structures of Python, which is an add-on in your syllabus in 2020-21. So today we are going to discuss about theoretical aspects of Python pandas. Friends, panda is an animal. Don't think we have to just put animal on Python. This is the data structures named after pandas. So let me move with that. Okay, so first we have studied, let me review you, that we have studied about a library of Python called Matplotlib. Now what is Matplotlib? Matplotlib is a library for creating static, animated or interactive visualizations in Python. So far we have studied area plot, histogram, scatter plot, pie plot and bar graph. So it is used for developing publication quality, using analysis, summarizing, and we should have the same full control of the fonts, access, we can export, we can save images. So it is very useful as we have earlier studied in data visualization. Now we are going to talk about a new library called Pandas. What? Pandas. It is the most famous Python package for data science, which offers powerful and flexible data structures. Friends, now I want to just tell you what are data structures. Data structures are the structures that make data analysis and manipulation easy. Means the way in which you are representing your data are called the data structures. We can import and analyze data much easier using pandas. So pandas built-in packages are one we have already studied, NumPy and Matplotlib. So both of these, Matplotlib and NumPy, are used for some specific purpose. For example, NumPy is used for numerical Python and Matplotlib is used for data visualization. So pandas give us convenient and single place, means it integrates data analysis and visualization work. So let me move further. How features of pandas help us in our working. First one is, friends, a new name here comes, data frame. What is a data frame? Data frame is an object that helps in keeping track of our data. Means we can keep track of our data. We can just हम check कर सकते हैं कि हमारा data ठीक है नहीं है, where it is going. Okay, now with pandas data frame we can have different data types like float, int, string, date, time. All are integrated at one place. All are integrated at one place. So after integration of these data types, third we have built-in functionality for easy grouping and join of data. Means we have several series through which we can contain a group of data at a single place. Good input-output capabilities means we can easily pull data from SQL directly into a data frame. It means connectivity part is there. With pandas, we can use Patsy for R-style syntax in doing regressions that we don't have to use. Tools for loading data into memory and from different file formats. This is of very much importance to us. As we will use CSV, we use Excel, we can import and exploit different types of data in data frame. So data alignment, integrating handling of missing data, reshaping and pivoting of data sets, label-based slicing, indexing, and subsetting of large data sets. Now let us move to the next slide, which is how we can install pandas. Friends, I have discussed here Anaconda Python package, but it is all same in Thorny also. We can do it as import pandas as PD. You have to write in shell. In Python shell, you have to write import pandas as PD. And then we can run it. Now, next thing is what we need for installation environment. We need any kind of window it can be. Next, it is we want NumPy, we want pandas, we want Matplotlib. So we can just install them in number of ways. PIP, program package installer, PIP install NumPy, pandas install 6. Now next, first data frame. There are two kinds of structures we are going to study here. Number one is series. Friends, let us have a look at this series. Now series is just like a one-dimensional array, means it is only having the size with homogeneous data. Homogeneous means same type of data we can save. Homogeneous means same type of data we can save. So we can have identical data in that. For example, the following series is a collection of integers. In it, I am taking 5 integers, 78, 45, 12, 89, 56. Now the basic features of series are homogeneous data. It means type should be identical. If we are entering like integer value, then it should be integer. If we are entering string value, then it should be string, or we are entering any other value, then it should be like that only. It contains data of identical data types. Now next is your size immutable. Friends, we have already discussed in class 11 scenario that what are immutable and mutable. Now I will again repeat it for you. Immutable means that you cannot modify after creation. It means we cannot modify it. It means we cannot modify the number of data or the number of elements, but we can modify the values inside a series. So let me again repeat it for you. Series is like a one-dimensional array that contains homogeneous data. For example, the following series we have shown contains the integer values. 3 basic features of a series are homogeneous data, size immutable, values of data are mutable. So we have to keep these things in mind, that size is immutable. We cannot modify size after once created, but we can change the values. Now next one is data frame. Now data frame is just like our 2-dimensional array with heterogeneous data. Now this is very common term. Heterogeneous means different kind of data at a single place, right? Different kind of data at a single place. So look, here I am having numeric data, then string, then date type. So basic features of data frame are heterogeneous data, means different data can be kept at a single place. Size mutable means we can change the size, even size of the data frame, such as height and width in 2D array at any time. And data is mutable means size and data are both mutable. Now if I will compare data frame and series, what differences I got? That in data frame, heterogeneous data is there, size and data both are mutable, that is that can be changed even after the creation. But if I will look back to the series, homogeneous data is there, means identical data is there, size is immutable and values are mutable. Now let me come to directly to the series here. Series, as we have already told, that it is one-dimensional array capable of holding data of homogeneous types, can be created using constructors. Now how we have to create? First we have to write import pandas as pd. Now pandas.series, in this we first have to give data, then the index value, then its data type, and copy is optional. Now creation is also of series is also possible through arrays. So we will use arrays, dictionary, or any scalar constant to create a series. Now from array we can create an array and put the name of array in place of data. In dictionary we will put the name of the dictionary, and any scalar value such as list we can take the list. So how do we write the pandas in pandas series? PD or pandas.series. If you don't want to take aliases, then data, whatever data you are taking, the index value, the data type, and the copy. Now how will you create an empty series? Now what I have done import pandas as p series. Now any variable that can hold this value, p series dot series pandas dot series and empty. It will create a blank or empty series of data type float 64. Float 64 means 64 bits. Okay. Now let us move with how we can create pandas through the dictionary. Now this is the dictionary. As you all know, dictionary contains key value pair, means there is a key and certain values corresponding to that key. So first example, without indexing, how we can create? Import pandas as pd1, numpy as pd np1. Data, a is the key, 0 is the value, b is the key, 1 is the value. So I will write s is equal to pd1 dot series and embraces data. So it will represent like my keys are there in front of them, their values are there. And data type is float 64 by default. Now if I want to take index, it means indexing will be according to me. Indexing will be according to me. Now friends, data which we are having has only 3 key values. Here I am describing for B, C, D, A. Now D is not there. So what it will be there in place of D? What it will be there in place of D? Can you think? We have defined the index in Python, and what it will be in place of D. In place of D, in output, you will be shown NaN. NaN means not a number. NaN means not a number. It means we don't have any number here corresponding to that particular key. So it will be showing NaN, and here indexes are given according to us values. So first, now friends, just have a look at here. Now B key contains 1 value, so 1 will be first, then C will be. Values are always corresponding to their keys. So whenever their keys are called or indexed, their values come only then. Creating a series from a scalar, what we will do, I have given a value 5. So it means all the indexes will contain the value 5. Means the number of indexes are there, 5 will be repeated there. If I want to make a list here, like I will write 5, 4, 3, 2, 1. So every index 0 is for 5, 0 is for 5, 1 is for next, 2 is for next, 3 is for next. We can create like that. Now, maths operation with pandas or series. Now friends, this is a very important thing, how you have to create a series and you have to use it, how you can create operations. Okay. Now, I have created 2 series here. So when we apply this addition operation or multiplication operation or subtraction operation on both of them, then what will be the answer? Now index, it will always show 0, 1, 2. If we will not give any index, the default values will be 0 because our indexing is starting from 0 itself. So in front of 0, the first value will be 1 plus 1. The corresponding elements, if it is first element, then first element will be added with the first element of the next series. So it will be 1 plus 1, 2, then 4, then 7. Now what it means? It means that we can apply arithmetic operations on a series of, pandas series, as many series we can take, as many operations we can apply. If we don't give indexing, the indexing will be by default. Okay, if we will apply here subtraction, that will be fine, that will work. If we will having some other arithmetic operation, that will work as it is, as it will be doing. Okay, so let me again revise it for you, how to create with scalar. We just have given the value and the scalar values are there. Now without index and index, we don't need to give any indexing value, and here we will give our index value. Okay, now next is create an empty series. Now p series dot series print s, pandas series pandas dot series. What we can do is here data frame, 2-dimensional heterogeneous data, size mutable, data mutable. Okay, now series is just like 1D array. Now script folder, how we have to install pandas, I have shown you. Okay, now what are the different features? Let me repeat: data frame, series, good input output capabilities. With pandas you can just use R style syntax for linear regressions, which we have taught in chapter number 1, data alignment and integrated handling of missing data, reshaping and pivoting. So this is for today. Now let me just wrap up with some points. You have to read data frame and series. What are data frames? Data frames are 2-dimensional data structures with heterogeneous data in which size and data both are mutable. And while we are working with that series, we are having homogeneous data, means identical type of data, in which there are 2 things, different things. Size is immutable, means we cannot modify the size after the creation of the data, and moreover the data is mutable. We can change the content, the elements anytime we want in the series. So that's it from my side today. Thank you very much. I hope you understood Very well. Students, now we are going to discuss about two more functions, head and tail function of the series, which is very important. Kindly put your attention here. So what is series? Series is one-dimensional data structure, or like an array which contains homogeneous data. Homogeneous data means series and same identical data in that. So data is mutable and size is immutable. So how to use head function and what its utility? Now head means it will return first three functions as we write. Head means we have to take first three functions from a dictionary or from a list. Here first three functions are 1, 2, 3. So we will use, if I will use head function and in braces I will write 3. So it will give 1, 2 and 3. If I will write 2, it will give 1 and 2. So head means first two or last two, first two letters will be given to you, and index, first two indexes will be there correspondingly with the list. So A is for 1, B is for 2 and C is for 3. Returns first three elements and data type is int 64. So how we have to use head series, which you have defined dot head braces. In that you have to write the number of elements or the number of elements from the series you want to take out. Now let me tell you about the tail function. Tail function does what? Tail function does the vice versa of it. It takes out the other values. It takes out the rest of the values, means the tail means the backside values. If I have written same s dot tail 3, then it will take out last three values 3, 4 and 5. It will be C, D and E, and three values will be there 3, 4 and 5. This is as easy as you can do. Okay, now let me come to the main point, which is how we can access data from series with indexing and slicing. This is just like array slicing which we have performed. So let me again tell it to you. I have made a series s is equal to pd1 dot series 1, 2, 3, 4, 5 elements, 5 keys or indexes are there. Now in big braces here I have written s braces 0. So what it will be? It means index position, 0 index position. Now 0 index position is 1. When I will print it, my answer will be 1. I have made an arrow for that. Now I have written s big braces colon 3, big braces colon 3. So it will be, what we can do after doing this, what we can do for colon, it means all the starting values till the index number 3. So till the index number 3, it is index number 0, it is index number 1, it is index number 2. Now in array slicing, I have already told you that the last term is not taken, it is neglected. हम नहीं लेते हैं. So it is up to index number 2. So first A is for 1, B is for 2 and C is for 3. We don't have to take fourth one because it is neglected. So index number 0, 1 and 2 are there. Now next is next is print -3 to further. -3 means negative indexing. Now negative indexing starts from here. -1, -2, -3, -4, -1. Okay, so we have to -3 से शुरू करना है. -1, -2, -3. I have started from -3 till further. So my answer will be -3 will not be included. This is -3. Sorry, -1, -2, -3. Okay. Now my answer will be 4 and 5. That is -2 and -1. Means -3 is greater than -2 or less. It is less. So we are moving towards the greater one. So -3 to till every value we have to take slicing for last three index values. So last three index values are 3, 4 and 5. 3, 4 and 5. 3, 4 and 5. Now let me again discuss it for you. We are having now this is head function. For head function we can just access whatever values from the starting we can get. For if we write head 3, it will get us 3. If I will write 4, it will get 4. Now the number of elements should be same because it should not be greater than the present number of elements. Now in tail we will get the value as tail, means the last elements. Now in accessing, it is just like array slicing. There is nothing else we have to perform. So I think this is very much clear to you, and take indexing very seriously, and you have to give indexing properly. Negative indexing starts from right, positive indexing starts from left. So remember this thing, and we will meet tomorrow with Python Pandas again. Thank you. Hello class 12. This is Tushar Aggarwal, your IP teacher, here again with your concept called Python Pandas. Friends, in yesterday's session, we have gone through what Python Pandas are, what is Matplotlib, we have took a quick revision at the Matplotlib, and now we are with the thing, what are Python Pandas. Now friends, what are Python Pandas? Pandas are the data structures. There are two things which we have studied, series and data frames. And in series, what we have learned, how we can create a series by using different methods, a scalar or some list or some other methods. Now today we are going to study further. After last we have done the accessing the list. Now we are going to discuss about the retrieval of the series. Now first point that comes into my mind is how to retrieve data using label as index. Means if only with the help of indexes, how we can retrieve our data. Only with the help of indexes, mind my words, only with the help of indexes. Now only with the help of indexes, how we can do? Now first step is import pandas as pd1. Now taken a series s is equal to pd1. We have taken as pandas aliases dot series. Now I have taken a values 1, 2, 3, 4, 5. Against them 5 indexes are there. Now friends, just see. When printing this series, I will use double big braces. First big brace is for values and second big brace is for showing that we are using the index. Now the index I will mention here will automatically pick the value, like C is having the value 3, D is having the value 4. So they will automatically pick the values and output will be there. Let me repeat it for you. Index are A, B, C, D, E. It depends on you or to the question what is given. These are the values against the indexes. Now remember one thing. If we have some extra index and no value, then it will be shown as NaN, not a number. Now we will use double braces instead of a single brace here. So S, C, comma D. C is index, D is index. So C index has value 3 and D index has value 4. Now let me move further. Now friends, how can we retrieve data from selection? This is very important part and I prefer you to go through this part very carefully. Now here we will learn about 3 functions, LOC, ILOC and IX. Okay, now LOC get rows or columns with particular labels from the index. Friends, this is your topic, that how can we access or how can we get rows or columns from a series. So with the help of LOC, we can get rows or columns with particular labels with indexes. Labels and indexes are there. Now what ILOC? At a particular position in the index. Means LOC will give you all the rows and the columns, whatever particular labels are there, whatever their index values are there. But ILOC will only give you or let you retrieve only those rows or columns which are at a particular position in the index. So it means its input is only integer, because index number we have to give, and index number cannot be 0.1, 0.2, 1.1, 1.2. It should always be 0, 1, 2, 3, 4, so on. And IX usually tries to behave like LOC. Means it tries to give you rows and columns with particular labels and index, but falls back behaving like ILOC if a label is not present in the index. Means if labels are not there, then it behaves like ILOC, and if labels are there, then behaves like LOC. Now this IX is depreciated and the use of LOC and ILOC is encouraged instead, because it has disadvantage of label and not labeling. But in LOC and ILOC, there is no disadvantage like that. So I think this is very much clear. LOC gets the number of rows and columns with particular labels from the index. ILOC gets rows or columns at a particular position in the index. Now I usually tries to behave or copy the characteristics of LOC, but falls back behaving like ILOC. Means इसका हमारे पास इतना use ही नहीं रहेगा, because we are trying to access LOC, retrieve LOC from the components like LOC, but we will fall behind if I will use IX. So IX is depreciated because it has a disadvantage as shown, and the use of LOC and ILOC is encouraged very much. So let us move further. Now this is how we have to use LOC and ILOC. Look, I have defined a series. This is numpy, np.nan means not a number. Everything will be given not a number. Nan will be displayed in front of every index. Okay, so I have given these things. Now I have used ILOC. S series S dot ILOC slicing means it will give up to the third index. Look, 49, 48, 47. 0, 1, 2. Third is excluded. Yes, we also know that third is excluded. The last term is excluded. So we will have data corresponding to the index, but in data we are having all the values as not a number. NA is not a number. So 49 is not a number, 48 is not a number, 47 is not a number. Yes, answers will be there. So ILOC gives you particular columns or rows that are specified. Now in LOC, what we are having, whatever will be there, we will get all and include label 3. Look, 48, 47 up to 1, 2, 3. Okay, now let me move to the 9 or IX. S.IX, the integer is in the index, so works like LOC. अगर ये index integer में नहीं होगा तो it works like the other thing. Okay, so slicing up to and including label 3. So कहाँ तक slicing होगी? जहाँ तक label 3 है, ये label 3 आ गया, label को इसने check किया कि yes we have to give values up to 3, so we have given values up to 3. अब यहाँ से आप लोगों को difference पता चलता है ILOC और LOC का. Now iLocation और loc. iLocation अब मैं इसका definite name बोलता हूँ, iLocation और loc. Okay, location and iLocation. Now iLocation means at the particular index, up to particular index the values can be given. Okay, and the location means all the values till the number is encountered. 3 is here, so up to 3, 49, 9, 48 NAN, 47 NAN, 46 NAN, 45 NAN, 1 NAN, 2 NAN, 3 NAN, 4 NAN. Sorry, 4 is not there, up to 3. Now IX, when digits are given or labels are given, it works like LOC. So it is the integer is in the index, so it is works like LOC. If there is no integer here, then it works like ILOC. Am I clear? Or I will repeat. ILOC uses particular index up to which we have to take the values. LOC use the values up to the label. This is the label, means the till the 3 is encountered, we can traverse the values or retrieve the values. 3 in index, remember my words, 3 in index. Now I9 is for labels. Now again I will not appreciate the use of IX or this 9. I will use iLoc or loc. ILOC or LOC is my preference. So friends, this is very much clear how to retrieve data from a particular selection. Now okay, now we have to move to data frames. Let me first have a quick revision of what data frames are. Data frames are heterogeneous, means different types of data, just like two-dimensional structure. Size and, I am repeating, just remember my words, size and data are both mutable, means size can be modified at any interval of time and also data can be modified at any interval of time. So now what is Pandas data frame? Let us have a quick revision. It is a two-dimensional data structure just like any table. Basic features of data frame: columns may be of different types, signs may be changed, labels, arithmetic operations on rows and columns. So this is the table which I am showing. It is having various fields, that serial number, admission number, student name, class, section, gender, date of birth. Now you must know how to differentiate between a column or a row. Columns are your headings, these are your columns. Serial number, admission number, student name, class, section, gender, date of birth. And the data, these are your rows, like the values which you have filled for the particular column are your rows. So these are the columns and these are the rows. Okay, now let me move further. Now a data frame can be created with following things. Number one, list, dictionary, series, look, numpy arrays, or some other data frames. So import pandas as pd1. We have to write any variable name here. Pandas dot D capital F capital. Remember this thing, you have to write D capital and F capital for that. Now it is data frame. In braces, here we will write it. Okay, this I have created an empty data frame where no columns are there, no indexes are there. Okay, so I am repeating, how can we create a data frame? A data frame can be created using list, dictionaries, series, numpy arrays, or any other data frames. Okay, now creating an empty data frame, we just write import pandas as pd df1 or any data frame 1 is equal to pandas dot. If you don't try to write aliases, if you are not interested in writing aliases, you can use import pandas. Then everywhere where is aliases, you have to use pandas word. So pandas dot data frame D capital F capital, that should be in uppercase, frame df1. Now output will be an empty data frame. There will be no columns and no indexes. Now creating a data frame from this, now one by one we will discuss all the things. For that I have created a list, and in data frame I will put this list. This is as simple as we can do. Okay, so it will pick index number automatically. 0 for 1, 1, 2, 2, 3 means at 0 index number value is there, at 1, at 2, at 3 and 4. I think this is very much clear to all of you, right? So we can write, we can define a list and put it here. Now example 2, if I will take a list like this, Freya 10, Mohawk 10 and all that, and I will write data 1, this is data 1, and only I want the specific columns. I don't want all the columns, or I want to name the columns. Then I can even name, like columns is equal to, this is first column name, whatever you will give, this will be your first column name, and this is your next column name, age. Okay. Now there is one more thing. If I have to change integer value, like 10 is there, if I have to change it to float, then I will use d type. D type is used everywhere in Python for data type. So d type is float. What is d type? Float. If I want to take as float value. So I am repeating again. Here I have taken data 1. Now I want to name the columns, like I want to name them, this is index and this is value. I can write index and value. Here it is taken as name and age, so we can write it as. Now how can we create data frames using dictionaries of arrays? How can we create data frame from dictionary of ND arrays? Import pandas as pd1, data 1. Now this is for the dictionary, this is key and this is value, this is key and this is value. Here I have written, this is simple. Now at first Freya is there, no, 9 is there, 2, Mohawk is there, 10 is there. Okay, if I want to run like indexing, so rank 1, rank 2, rank 3, rank 4 we can use. Now how can we create a data frame using, now I am using both the things, list and dictionaries. Now how can we create a list of dictionaries? Now first we have to make a list. Okay, this is what I am doing, list inside dictionary inside a list, dictionary inside a list, dictionary inside a list. So in this is called dictionary inside a list. X key है यहाँ पे 1 value है, Y key है 2 value है, X key है 5 value है, Y key है 4 value है. So I have written as data frame 1 is equal to pd1 dot data frame data 1. So what will be my output at index 0? X will be 1, Y will be 2, Z will be NaN, because there is no value corresponding to Z here. Now again X will be 5, Y will be 4 and Z will be 5, because in second dictionary we are having the value 5. Okay, and if I want to give only the above program for indexing, so I can write index first comma second. So first it will be here, second it will be here. So in data frame I can give it all. I can give the name of the indexes, I can give the name of the columns, just like that. Okay, I can give the name of the columns. So there are many things we can give data type as we want. So these are 3 ways which we have studied how we can create through list, how we can create through dictionaries, and how we can create it through the list of dictionaries. Means list and dictionaries are both embedded. Okay. Now dictionaries contains key value pairs, so dictionaries can be embedded within the list. So I will use big braces and then the list. I think this is very much clear to all of you.